For more than a decade, GPUs have been the backbone of modern artificial intelligence. When AI models started growing larger and more complex, GPUs were the best tool available. They were fast, parallel, and already proven at scale. As demand increased, the solution seemed obvious: add more GPUs. But Cerebras exists because that approach started showing limits. Not limits in speed alone, but limits in design. Cerebras was not built to compete with GPUs in the traditional sense. It was built to question a basic assumption that AI must always be spread across many small chips working together. To understand why Cerebras is different, we first need to understand how GPUs actually work in AI systems. A GPU is a powerful but compact processor. On its own, it can handle massive calculations. The problem is that modern AI models rarely fit on one GPU. They are too large, so engineers connect many GPUs together into clusters. These clusters rely on constant communication. Data flows from one chip to another, layer by layer, step by step. This works, but it introduces friction. Every time data moves between GPUs, time is lost, power is consumed, heat is generated. Even with fast interconnects, communication becomes a bottleneck as models scale up. The more GPUs you add, the more coordination is required. At some point, you are no longer limited by computation, but limited by movement. Cerebras was designed around this exact problem. Instead of cutting a silicon wafer into dozens of small chips, Cerebras uses the entire wafer as one processor. This is not a marketing phrase. It is literal. The chip is as large as the wafer itself. Compute units, memory, and connections all live on the same piece of silicon. The goal is simple: reduce distance. When everything exists on one chip, data does not need to travel far. There is no external communication between processors, no synchronization across separate devices. The entire model can exist in one unified space. This is the core difference. GPUs rely on scale through distribution. Cerebras relies on scale through integration. That choice changes everything. Memory access becomes faster because it does not cross chip boundaries. Latency drops because communication stays internal. Engineers spend less time managing hardware orchestration and more time focusing on models. But this design also comes with trade-offs. A wafer-scale chip is not flexible in the same way a GPU is. GPUs are general-purpose accelerators. They handle graphics, simulations, AI inference, and training. Cerebras is specialized. It is designed almost entirely around large-scale AI workloads. That specialization is intentional. Cerebras is not trying to replace GPUs everywhere. It targets environments where models are extremely large, training times are critical, and communication overhead becomes the main bottleneck. Research labs, scientific computing, large language model training, national scale infrastructure. In those contexts, reducing complexity matters more than versatility. Another important difference lies in how scaling works. With GPUs, scaling usually means adding more units. That increases raw compute, but also increases complexity. Networking becomes harder. Debugging becomes more difficult. Performance gains flatten out. With Cerebras, scaling happens inside the chip itself. The architecture is designed to handle large models without breaking them into pieces. That makes scaling more predictable, even if it is not as flexible. This is why Cerebras systems often replace entire GPU clusters for specific tasks. Not because they are universally better, but because they avoid the overhead that clusters create. There is also a philosophical difference at play. GPUs were adapted for AI. They were never built specifically for it. Cerebras was built with AI as the primary purpose from day one. That influences everything from memory layout to data movement. This does not mean GPUs are outdated. GPUs remain essential. They are easier to deploy, widely supported, and deeply embedded in existing software ecosystems. Most AI workloads still make more sense on GPUs, especially when flexibility and cost matter. Cerebras operates where assumptions break. It exists because some problems no longer scale well with traditional hardware. As models grow larger and training cycles become more demanding, efficiency becomes more important than versatility. This is why Cerebras feels unfamiliar. It does not follow the incremental path. It does not fit neatly into existing data center logic. It challenges how engineers think about building AI systems in the first place. The difference between Cerebras and GPUs is not about speed alone. It is about architecture. One spreads intelligence across many small units. The other concentrates it into one massive system. Neither approach is universally correct. They solve different problems. And that is the most important takeaway.